General angles and radian measures. This is the online lesson for lesson 5.2. Now before you start this lesson, you need to have a ruler or straight edge, and you want to have 4 colored writing utensils other than your normal pencil or pen. So colored pencils, markers, highlighters, something that you can get 4 other colors. Because you're going to need that later in the lesson. So if you don't have those things, pause the lesson right now, go find those things, and then come back to start again. All right, so in our previous lesson, we were talking about trigonometry with respect to right triangles. And in a right triangle, our trigonometry always happens with acute angles, because they're always the angles other than the right angle in the right triangle. But we don't want to be limited to just acute angles when we're talking about trigonometry. So we have to go beyond just right triangles in order to expand to all of the possible angles with which you can do trigonometry. So in order to do that, we need to shift our thinking from right triangles to more of a rotational kind of diagram. So that's what you see here at the left. You can see here that we have an axis of a coordinate plane, and our horizontal axis is x, our vertical axis here is y, and you can see here that they have labeled the positive x-axis as the 0. So if you think about a ray that starts here as the positive x-axis, and then another ray that would start rotating from there and maybe stopping right here, when this ray stops, we've just created an angle. And so this ray can rotate as much or as little as we desire and make all kinds of different angles. Acute, right, obtuse, things that go beyond 180, things that even go beyond 360, because this rotation can continue over and over and over again. We are not limited by just a single rotation. So this starting place, this ray where we would start, is what's called the initial side. It is the ray that is going to stay fixed. So it's our starting place and it stays there. And then as we rotate, the ray that is going to do the rotating in order to create the angle, that's called the terminal side. So it's the side that's going to determine where we end or terminate, and therefore what kind of angle we end up with. And of course, as always, this point where the two rays meet is our vertex of the angle. Now, we often refer to angles as being in standard position. And what that means is, in a coordinate plane like you see here, we need our initial side to start here on this positive x-axis, and we need our vertex to be at the origin. And when that's the case, then we say our angle is in standard position. And that's usually what we want when we're doing trigonometry. Another term that you want to be familiar with is the term coterminal. Coterminal angles are two different angles who have terminal sides in the same spot. So maybe I have this angle here. Let's say that maybe this is a 135-degree angle. And then maybe I have another angle that went this way around. So maybe that's a, let's see, that would be like a 225-degree angle in this direction. Those would be two angles that would both end here with this ray. So their terminal sides would coincide, and therefore they would be called coterminal angles. That's a phrase we're going to be using in class during our lesson, so keep that in mind. Oh, before we do that, one other thing I want to point out here. Notice that the rotation they're showing here and the numbers starting here, starting here with the 0, notice that our numbers proceed in a counterclockwise direction. Okay, that's important because if you are given a positive measure for your angle, then that tells you that the rotation had to take place in a counterclockwise direction. Okay, so counterclockwise is considered positive. If you are given a negative measure for the angle, then what that tells you is that the angle had to go in a clockwise direction, that number of degrees. So if I rotate this way around and then end up with a ray down here, this angle would have to be a negative measure, like maybe a negative 60 degrees or something like that. Okay, so that's another important thing to keep in mind. Positive angles have to be measured in a counterclockwise direction, while negative angles are measured in a clockwise direction. All right, so when we actually measure angles, again, when we were working with our triangles, the angles were measured in terms of degrees. And that's very common with triangles because we're used to talking about the degrees of the angles that make up a triangle. But there's another unit that can be used for measuring angles, and that is called the radian. Now, a radian is kind of a strange unit because technically in science there is no unit for a radian measure. That's actually why radians are used in more scientific kinds of situations, because when you do the unit analysis to see how the units cancel out, radians are a unit that do not have to be considered. So it's kind of a strange concept to get your head around. But for right now, I just want to show you where this idea of a radian comes from. Okay? And so we're going to use this little diagram here. I'm going to show it to you once, and then you're going to see it a second time. So here's what happens. With a radian, you want to take the measure of your radius. Okay? And then if you take that measure and you measure it along the circle itself, okay, so you saw how this measurement here, they flipped that along this point, and then they're measuring it here. So here you're going to see it again. So they're measuring it right here. The angle that creates that much of an angle is considered to be 1 radian. Okay, now if you keep overlapping those, you find that there's 3 full radians and then a little bit extra here that make up a half of a circle. Well, that little bit extra happens to be the 0.14159 blah blah blah, which ends up giving us pi. So there are actually pi radians in a half circle. Well, we also know that a half circle ends up giving us an angle that is a straight line, or a straight angle, which is 180 degrees. So pi radians is the same as 180 degrees. It is half of the rotation around a circle. That also then leads to the fact that all the way around the circle, 360 degrees, is the same as 2 pi radians. So 1 pi radian for half the circle, 2 pi radians to go all the way around the circle. Okay, now that's an important equivalence to keep in mind, because again, one of the things we'll be doing in class is converting back and forth between degrees and radians. And the way that we do that is going to depend on this equivalence, the fact that 180 degrees is the same as pi radians. Okay, but that whole idea of what a radian is comes from taking whatever your radius is, laying that length along the circle itself, and then the angle created by that is going to be 1 radian large. Okay? All right, so let's take a look at some common angle measures in terms of radians. And here's where you're going to want your ruler and your different colors. Okay, so based on what we just saw, we know that half of a circle is 180 degrees, which is the same as pi. So using your normal pen or pencil, draw a line across your circle that's on the back of your page. It says common angle measures at the top of that page. Just draw a line across the x-axis there and label that with a pi right here. Okay? Now, if we take that and divide it in half, then we would be right here. So now we're talking about 1/4 of the circle, or half of the half circle, which would be half of pi, which we would write as pi over 2. So we can see here that an angle that starts here at the initial side and only goes up this far is going to be a pi over 2 radian measure, which we can obviously see is the same as 90 degrees. Now if I divide those two sections in half, here on the first quadrant section, dividing that in half means I'm taking pi over 2 and then taking half of that. And so that's going to give me pi over 4. So this much of an angle has a radian measure of pi over 4. And again, since that's the same as dividing 90 degrees in half, pi over 4 is the same as 45 degrees. Now if I also divide this section in half, what happens is I can actually count by fourths here. So here's 1/4 pi. Then I would have 2/4 pi. But if I simplify 2/4 pi, or 2 pi over 4, it would simplify to this pi over 2 that I already have labeled. So I don't need to relabel that ray. But then if I go another section, now I'm looking at 3/4 pi, or 3 pi over 4, and that's another one that I can label here. And then one more section would get me to 4/4 pi, or 4 pi over 4, and that simplifies just to the pi which I already have labeled. Okay, so if you need to take a second to draw those out on your paper, pause this at any point so that you can be drawing these in. But I really want you to draw them in using the different colors and then labeling them according to their radian measure. So take a minute to pause this if you need to before we continue on. All right, now we can also divide this pi, this upper half of my circle, by thirds. So if I do that, it's going to look like this. So here's 1/3 of my top half, here's another third, and then here's one more third. So obviously up to my first ray is going to be 1/3 pi, or pi over 3. If I go the second section, I end up over here on this orange ray, which has not already been labeled with anything else. So that's going to be 2 pi over 3, or 2/3 pi. And then if I go this third section, that would end up giving me 3 pi over 3, which would, again, simplify down to pi. So pi over 3 and 2 pi over 3 are two more very common angle measures that we need to be aware of. And then if we do the same thing that we did on the previous screen and divide each of these sections in half, now half of pi over 3 is pi over 6. If I go back here for just a second, because I'm now looking at sixths, I have this line here to divide this one in half, but it's not really necessary because I've already labeled that line before with the pi over 2. Okay, and you should just be doing all of this on the same circle. I know I did it on 2 different circles, but I want you to end up with one circle that has all of these different colors and all of these different angles measured on it. So since this is a line we already labeled, I really don't need it. But I can label this one with pi over 6 now because that's half of the pi over 3 section that I had. And then with pi over 6, a lot of these are already labeled because of what they would simplify to. So this would be pi over 6. Then I would have 2 pi over 6, which simplifies to pi over 3. Then I would have 3 pi over 6, which simplifies to pi over 2. Then if I go all the way over to this orange one, that's the same as 4 pi over 6, but that simplifies to 2 pi over 3, which is already labeled. And then I finally get one more section here that has not been labeled, and that puts me at 5 pi over 6. And then finally the last section here would take me all the way over to pi again, because that would be 6 pi's over 6. So when we put it all together, your top half should look like this. Now in order to label the bottom half, we just reflect all of those rays through the bottom half. So each color that I drew up here, if I continue that ray so that I create a line, it's going to remain the same color, which means it's going to keep the same denominators as I go around the circle. So if I continue to label things as we go, we can see here that the 6 would continue past 6 pi over 6, which is our pi, so that I get 7 pi over 6. My force right here would be 4 pi over 4. That continues one more section to 5 pi over 4. And then my thirds here, one more section here got me to pi, an extra section after that gets me to 4 pi over 3. So you can just keep continuing to count around the circle with whatever size sections you're using to label the rest of these, the rest of these until you get all the way around to the 2 pi. So again, if you need to take a minute to pause this and get the rest of this drawn in, this is the final circle that you should end up with on your page with the different colors and the Radian labels. So pause again for a moment if you need to and get that far. All right, so finally, radians and degrees can label the same angles. So I want you to take a second right now and see if you can go back and label the degree measures for each of the radian measures that we just labeled. I think you can figure these out based on what we said and based on some previous knowledge. So try to do that and then come back when you're ready, click to begin, and I'll show you what it should look like with the degree measures. All right, so here's your equivalent degree measures. So ultimately what I would like you to end up with is a picture that looks like this with the 4 different colors, and at each angle you should have both the radian and the degree measure as a diagram that you can reference for our upcoming lessons. Now I realize that that was a longer video than usual. I hope that didn't ruin any evening plans for other things that you needed to do. But this is going to be some really good information that we need to use and be able to work with as we proceed in our next lessons. So take some time, understand this, and quite frankly, we're going to get to the point where we're going to have to start memorizing this. So the more that you can visualize this on the circle, the easier it's going to be to memorize it when we get to that point. So take some time, make sure you have a really good diagram, and that will help you with what's coming up in the future. And speaking of the future, this will prepare us for what we're going to do next class, and that's when I'll see you next. So have a good night.